start with some PowerPoint slides, and I'm going to sort of go around over some things to think about if you're working on becoming an efficient coder that are for Python but can be applied to any kind of thing. We're going to move on a little bit from that to do some very basics of Python. For people who are just learning Python for the first time, and just learning any programming language, this will be like a super helpful core thing. And I think for the people who are used to R or other languages, it'll be like that little thing that you're missing when you read Python code. We're going to jump on from that part to do sort of work through an introduction to sort of data analysis and how to work through a data set. You can go to the GitHub at any time if you're bored and try to download that. And you can see the notebooks that we're going to go through, because we'll be using the Jupyter notebook today. And I put something in there for advanced users. So if you're sitting here and you're like, man, this is going way too slow, go open that book. And I think you'll find some things that are really cool and for you to like think about, and we'll push you a little bit. So I think Pamela just went over a lot of this, but I have a slide here. DataLab, badass, use their services. That's what allows us to be here today. So let me just sort of start by saying, like, if you haven't gotten, like, if Python isn't running, like, you should get that started like right now. And I would say I would recommend using Conda. This is probably the core Python manager. If you install the Conda, you can do it on the command line, and it'll or with a double-click package, and it'll install most of the things that we'll want. Not just in this workshop, but like in general, like you know, most of the packages that are tried and true are going to be in this.
So,
oh yeah.
On the website, it suggested Anaconda rather than.
Oh, sorry. Conda and Anaconda are the same thing. The Anaconda, it used to be, it's conda.io is the new version of the Anaconda thing. But if you install Anaconda, it just goes to it'll download the same stuff. It should. It did when I did it.
That's Spider. That's my access to.
So you can use Spider. So it should install a bunch of things with Spider included. But we'll use the Jupyter notebook, and maybe I can come around when we get started with that. I want to say, you know, in this workshop, you will learn. I think often people come to workshops like this, and they're like, "Yeah, I'm going to learn Python," or like, "I'm going to learn some, you know, tricks in Python," or maybe I'm going to learn Python for data analysis, although I do kind of love the shrew. I don't know why that one's my favorite. I think really what you'll see is that like the most common way of coding is Googling for error messages and copying and pasting from Stack Overflow, right? What I really hope that you learn in this workshop is just a little bit of Python, a little bit of how to organize projects to facilitate reproducible science, and then hopefully we'll get to the point where we can start showing you guys how you can make things that are way fancier than your programming skill level using Python packages. And there are a lot of Python packages that provide some really great, cool opportunities for how we can push things forward. Now, I don't want to give anybody the wrong idea. Coding is hard. I've tried to organize this so that there's a little bit of something for everybody, and so that we can work through these things together. But you know, the reality is the real resource that you're getting from coming here, you know, my banter aside, is the opportunity to download these notebooks and deal with them later, right? You'll do a little bit here, but really it's like the longer you dig in, the more you think about this, the better off you're going to be. And you know, this is not going to turn you into a software developer. Now, I just want to give a couple of little things that I give at the beginning of like any programming class that I'm teaching, which is you got to comment your code. I see so many times when people start their code, they like get to a point where I assume many of you are, where you're writing like a little bit of code and you're starting to feel useful in your programming life. And then you show your code to somebody else and they're like, Jesus God, right? And I want to push you a little bit today to think about, like, I want to remind you guys that the code should be the what, right? Python is intended to be readable. Somebody should be able to look at your code and sort of go through line by line and be like, okay, right? The comment should be the why. right? The comment are going to really help you unpack what's going on, right? In Python, comments are generated with a hashtag at the beginning of the line. In the Jupyter Notebook, you can also create a markdown cell where you can put formatted text. And either is OK as long as you are clear. Now, just to be super clear in this point, don't do this, right? It's like for D in my list, D get data, print D, right? This makes two mistakes. One is that this code is terrible, right? Not because it's not like this looks elegant, right? It's because you named it my list, right? Because you named it D. It's like, oh, nobody's ever going to be able to understand what you're trying to do, right? So I would say you should do something like this for subject in subject list, subject data equals get data of subject, right? You can do something a little bit like that to be a little clear, but I would say like this amount of commenting is probably a little bit too much, right? If you do something like this where you just say print data, again, you're not being specific enough and it's probably a little bit too little. And I would encourage you to think about comments that are along these lines where you can say like get and print data for each subject, and then you can write your loop that should be readable, or your loop here that is readable to somebody who just walks up and looks over your shoulder, right? Throughout the workshop and then just in general when you're coding, one of the most common frustrating parts about learning to code is getting stuck. It happens to everybody. In the beginning, you're going to get stuck pretty frequently, and your eyes haven't been trained to see the errors. To minimize how much this happens, I find it helpful to quickly disengage when you can't get something to work. So, I would encourage you, like when you were sitting here, when you write a little bit of code, you run something and you're like, it erred, okay, right? Google it again, stop Googling and ask, right? Like, don't perseverate. And I think one of the things that wastes a lot of people's time when they're learning how to code or when they're really first getting started is that they'll just like stare at this one line for hours and hours and hours and hours, and then they'll show it to me or to somebody who can read Python, and they're just like, oh, you missed that. It used to be like in C, it was like, semicolon, right? So I hope that you guys can do this. And then I also run a, copy and paste Stack Overflow. And then I run a PUG, which is the Python user group meetup. Pamela made this amazing logo. I would use the word amazing. So this is, we meeting this quarter from 3:30 to 5 p.m. on Tuesdays. And I would just say, like, this is a really good place to come when you get to that point where you're like, yeah, I was trying something. I Googled it a couple of times. I didn't know what I was doing. If you drop by during this, I can probably help to answer that question. It's also a good time to come by and ask more sort of general questions about what it is, or a place to get into the habit of writing Python code if that's something that you're trying to make time for in your busy, busy lives. So do we have any questions so far? I think everything is pretty straightforward. Cool. Because now I want to talk about why we're here. And I think the underlying thing that I think everybody in this room knows is that computers are becoming increasingly useful, enabling new kinds of approaches to science, right? Data rules. Maximal data can lead to maximal insight, and we are better prepared to deal with it. And I absolutely love this paper, The Unreasonable Effectiveness of Data, that's kind of a rip on some of these, the unreasonable effectiveness of math, right? And in this paper, this is written by a couple people at Google, and they sort of pointed out that this is the amount of words that things are trained on, and this is the test accuracy. And basically, there's just 4 different algorithms, and you can see that like when they were starting out, people were like, oh man, we got from 75 to like 82%. We got like a 7% increase in our accuracy by using this new algorithm. And but it turns out if you just train on increasing orders of magnitude of data, the order of those algorithms flips, right? And in order to achieve the accuracy that we want to achieve, it often requires more data and more ability to use that data and deal with it than really clever algorithms and approaches. So why Python? Honestly, I use Python a lot. I wouldn't say that I have a really strong reason for Python over other languages, though I do prefer it, right? Python is free, open source. Most people use it. Questions can be Googled. It does so a number of different things well. It tends to be fast. That's one of the main reasons. I think R is getting faster. Everybody keeps telling me that. But when I started to use R, it took like forever to load in big data sets. And if you could use MATLAB at the time, and MATLAB could load them in pretty quick, but then you had to pay $700 to have access to MATLAB. And so I switched to Python. It tends to be easy to read, generally follows the rules of what I would refer to as a good language. It works well with other tools, and there are a number of useful packages, some of which we'll talk about today. But I want to sort of talk about this Zen of Python, which is one of the things that sort of started out this Python and drives a lot of the design of packages. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. And although practicality beats purity, errors should never pass silently. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea, right? And I would really encourage you guys to think about this as you sort of start trying to be Python coders, because this really is something that I think, at least for me, really pushes me to try to write code in the right ways, not in the way that feels right to me right now, because it got me through this like weird debugging situation that I found myself in. Another thing that I want to point out is this idea of a data stack. So we have, if you have a kitchen, you can explain the idea of cooking to somebody by saying like, oh, you take like X ingredients, right? You do something with them. You have a list of steps that you do with them, and then you go and you make your cake, right? The idea of a data analysis, and I think this very quickly happens when we talk about working in like a notebook setting or something. So it's like really easy for us to like go reorder things and do things out of order and do things as they occur to us. It ends up being a really messy project. And I would really encourage you, as you think about being a legitimate coder, trying to take this into your science or into your lives, I would say this is something that's really worth looking into. And I want to tell you briefly about this guy, Jeffery Chang, in order to make this point to you. So Jeffery Chang published a lot. He had this really great ability to identify this X-ray crystallography techniques, right? He like made some really key development of techniques. He was really good at this. He published Science, Journal of Molecular Biology, PNAS. This guy was killing it as a scientist. And some people felt like some of his things didn't make a lot of sense. And so finally, some group figured out that sort of technique that he'd been using in the lab, and they classified a very similar molecule, shown in green here, and they found it didn't much match his purple. And when they saw this means nothing to me, but when they saw this, they were like, oh, Jeffery fucked up. Right? And so Jeffery did totally F up, and he flipped 2 columns of data. So that resulted in the wrong structure from the molecule. It resulted in a lot of retractions, which if you can imagine how good you feel when you publish a science paper, imagine how terrible you feel when you retract 3 of them in the same day. So good news is Jeffery admitted his mistakes. He is now doing okay. He's a well-funded professor at UC San Diego. But people have argued that he set his field back by about 5 years, right? So how do you make sure that you don't do this? This is a terrifying thought. I run a lab. I have graduate students who are writing code. How do I make it? It's going to be fine, right? So I would say document your code, obviously, right? Test your code. As you become a more serious coder, you're going to benefit from running code tests. If you're just learning, it probably doesn't make sense for you to start implementing this right now. But if you know what this means, if you know what a code test is and you're not using it, stop it, right? You'd be foolish not to keep these in mind moving forward. And for now, just remember, if you edit working code, you should rerun it on some data that will give you a known result. And in order to make sure that you don't make mistakes, you need to stay organized and stay organized, right? And that's part of this idea of a data stack style of organization. I use this cookie cutter better project templates, which is basically a template for Python projects. The GitHub that I use for this class, it includes that. Today, we're only going to be using notebooks, data raw, data processed, and reports figures. But if you go, I mean, you can see that there's a lot more organization that they try to set up for you. And I would highly encourage you to go check it out. And the link is also in the notebooks. So, all right. Are there any questions? This is sort of general overview stuff that I feel like we don't think about this stuff enough. So I'm just like, hey guys, we're doing this. Sorry. Yeah. Yeah. So I would say that for the example that I gave, the what is stupid, right? Like the why is just like to give you guys an example of a comment, right? So I agree. I think that there's something there, but I think it becomes very clear what that is when you start to write. Like you'll see in some of the notebooks, I always try to add a markdown before a section of code that just has the question that I'm trying to answer, right? If you have a function, you shouldn't say this function will run a loop on the first 14 subjects and then, right? It should be like, this is a function that takes X and Y as input, fixes it, and returns Z, right? And that's like this is what we're trying to get, right? It's the fixing part. So as a side note, if you know R, the Jupyter Notebook, which we're going to be using today, is called Jupyter because it's supposed to be for Julia, Python, and R. You can run R in the notebook, and you can actually use R magic in Python notebooks. And in theory, you can switch back in between them. I would say that this is like a fairly advanced move. And you have to get everything installed in the right way, which is sadly non-trivial. Basically, what you have to do is you have to install R with links to Python and things like that. And I would say, in general, it's often a bad idea. If you want your code to be readable, don't write in more than one language, right? It's like, I wrote a note to my wife. It was half in English and half in Dutch. It's pretty easy to find PDFs of programming books. There are two kinds of books that I think are useful if you're going to take this sort of task on. There's some books that are about the language you're learning. Those are O'Reilly books in general are the best, and that's true for Python. But I would say that if once you're beyond the level of actually how do I write a loop, I would say most of what you're going to get is from books like The Design of Everyday Things, Linux and the Unix Philosophy, and The Best Software Writings. And these are books that are on design, algorithms, and organization, right? So these are a few examples of some of my absolute favorites. This Design of Everyday Things is one. It's like a book from the 70s with like a teapot where the handle is on the same side as the spout, right? So, all right. So right now, I think we're going to jump to starting out with some basic Python. I think now is a time where if you can't run Jupyter Lab, the way that I run Jupyter Lab is I go to the terminal program on my Mac and run it by typing Jupyter space lab. And now would be a good time to open that up and try to get that going. You can also download the code that I'm going to run by cloning this Git. And I'm going to use 3 notebooks today: the basics of Python, the introduction to data munging and plotting, and then some advanced cases. And this is the notebook that I would say, if you get bored, go look at that one. And it'll do some things that are cool. All right. I gotta not just tab over, I have to escape my PowerPoint. Then you can see my screen. Boom. All right. So your Python notebook will open up something like this. Over here, it has some sort of navigation buttons that you can click on. This button will show you what notebooks are running right now. This button will give you like a file browser. So if you ran it from the directory with the Olympic data, you should see something like this. You should be able to go into notebooks and find notebooks that we're looking at. I think that I'll show you a couple of little additional things. So you can look at data in here. You can just drag in a CSV and you can have it here. And this will be helpful. This will be useful for us as we try to read in data. And that's one of the sort of nice things about the Jupyter Notebook. The other thing that I want to introduce you guys to pretty quick here. So if if we open up the basics of Python, we can do something where we go into help and show contextual help. And so this show contextual help over here will allow us to do something like, say a function is a equals and it'll just tell us what this object is. So I just click next to it, and this just updates the help. So I'll show you a little bit of this going through, but is there anybody who wants to be looking at this notebook and is not? Did you get the Jupyter Notebook open? Yeah. Yeah. Yeah, so what you'll have to do is you'll have to go, maybe it's better if I just close them. If you downloaded the GitHub and you go into notebooks, you should be able to double click and it'll open. Yeah.
Is there any chance you could make the font a little bigger?
Oh, yeah. 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 Please feel free to tell me when you do that. I'm like a little bit spacey when it comes to font sizes, especially since my eyes like generally work, and then I'm like, oh, what do you mean, guys? What do you mean? I can see fine. Okay, so Python is what is referred to as a fully functional language. Python can be run in an interactive mode. You can access that in the IPython notebook by adding a console, right? So this would be in general, I prefer to write code in the notebook because it just allows like a nice visible record of what we're doing. Python has a bunch of packages which extend its functionality, and Python is fully object-oriented. Python is white space based. That means that you will eventually get an error if you start writing code in like a old school like VI kind of text editor. You'll eventually get an error that says like this code is improperly indented because you're using tabs and spaces interchangeably, and it turns out that's not okay, right? And Python has data types. I'm going to talk about this a little bit because in general, when we talk about jumping into a programming language, the main error that you will encounter for the first 6 months or so, year or so, lifetime or so of coding, the most common error that you're going to come across is a type error, right? Or something that is arisen as a function of a type error. And so it's really important to just think very specifically about what that means and what these are. So when I say things are object-oriented, it's most things, the methods versus values, most things in Python are objects. The values are the data that are stored inside the object, and methods are the functions that an object can perform. And I think here it's best to learn by example. So if we do something like, say, a equals 8, print a. Right. Now we've set a to be 8, and we've printed it, and everything seems good. Now, you can create a new cell. I'm using below your cell, so you can do that, I think, under like run and add cell below or somewhere. Run selected cells and insert below. You can also do it on the keyboard shortcut with Control M to get into the, I guess I should probably say this, sorry. In the Jupyter Notebook, there are 2 modes that you can be in. You can be in a editing cell mode or in a control mode. This is much like a VI or like an Emacs type thing, for those of you who know what that means. In the control mode, you can add cells, delete cells, things like that. In the edit mode, you can type in something into the cell. So if I hit like Control M, I'm now, you can see that my cursor disappeared from here, and I'm now in the mode, and I can hit something like the letter A, and I've added a cell above where I was. Right? So I can do Control M, DD to delete, and now I'm back. And I believe those are all in there, like keyboard shortcut reference, wherever that is. Oh yeah, I think that's here. Yeah, like delete cell, and it'll tell you what keyboard shortcuts are. Okay, so now that we have A is not just a integer, right? A has a bunch of functions that it can run. So I can do like A of conjugate function, denominator, real, numerator, all of these things. It's worth noting that if I say B equals 8.0, and I say type A, let's print type A, print type B. Hopefully my fingers will get used to this keyboard, right? I now have 2 things of a different type. So one is an integer because I initialized it with no decimal point, and one is a floating point number because I introduced it with a decimal point. Now, what's really critical about this is that in Python, A and B can do different things, right? So if I go over here and I just select A, you can see it has a little documentation over here, and it tells me things that it can do. And if I type B, it's going to tell me other things. And if I type .tab, it'll do this. Jupyter Notebook will pop up all of these different things that I can do to that object. And this becomes really important if I'm doing something like using a number to index where I want to be in a data frame. You can't use a float to do that, right? And it'll tell you, you can't index using float. Right? So we can do things like b dot bit length. Anything that ends with parentheses is going to be a function. Anything that ends with a dot is going to be accessing something within the object that we're in. Right? So I think, I don't remember, oh, did I do that wrong? Because it doesn't have bit length. It is integer. True. Right? So here I'm doing, this is an object, dot, and then that's doing something of that object. And then I have the method or the function. And then if I do it with parentheses, it'll do that. If I do the same thing where I don't put the parentheses at the end, it's going to tell me, it's going to return to the browser a function, right? And what's actually going on behind the scenes in the Jupyter Notebook is it's actually running some bit of code. It's sending it to a tiny little web server that's running on your computer. That web server is running Python code to produce a result, and then sending it back to your web browser as a nice little element. People feeling okay about this? Is this too abstract or is it too slow? Yeah. Oh.
When I do like .tab, I get the list, but there's just plain text. I don't get that nice like what type of thing this. Is there some kind of setting change?
My bet is that your Jupyter notebook is not the, you're in notebook and not lab. Is that possible? Did you have a question?
Well, I'm not seeing exactly what you're seeing, so I'm somehow in something different. So I don't have the contextual help on the right.
So I added the contextual help on the right by going up to the here and to the contextual help.
Yep.
And if that,
I get separate pages.
yeah, okay. So if you get separate pages when you do that, that's effectively because, let's see, contextual help, it goes like that, but I can drag these around. So I can drag.
Okay. And then in the way that I'm doing it, I'm having to click each time to get things to run rather than.
Sorry, I'm also running using a keyboard shortcut, so I'm just doing a shift enter. Will run and then move you onto the next cell, and a control enter will run the cell that you're in and not move below. Sorry.
Okay.
These are things that like my fingers have just done for so long. I forget that they're a thing. Yeah.
I'm using the Windows version of DataLab, and I couldn't load the basics of Python notebook. It says file load error for basics of Python. Unreadable notebook.
Has anybody else had that? I think my bet is that if you try to re-download it, that shouldn't happen because I just had to reinstall Jupyter onto this computer like in the last couple days because it's not my computer.
There's a red sticky and you'll get over when.
Okay, so basic idea here so far, we've just covered like everything's an object, everything that we're looking at, we have thing, dot, function, it'll return the function itself. So if you get something that looks like this in your output, you know you're looking at the function itself, not the thing that you're trying to get out of that object, right? So if I do something like this, now all of a sudden I get the output of the function, right? Yeah.
So as a primarily R user, this whole thing where the decimal matters really threw me for a loop when I started beginning to learn Python. So I just want to emphasize that like I was used to be naming my variables in R like survey.1 or something. That's obviously not going to work when you're working in Python. So just kind of be ready to switch that mental framework where the syntax is different.
Yeah, so there are things like that for me where I came from like programming like C and Java where I was like dot something is in a name. I was like, oh no, right? This is terrifying. But I think it's one of these things where you'll get used to it pretty quick because you'll see how badly your code errs. Also, I would recommend if you want to do things the right way, there are ways that you should organize your code in like nomenclature things that are specific to language. So they say like in Python, you should name your variables with lowercase and underscores, not with uppercase mixed together and things like that. You should only use the uppercase mixed together when you're naming some kind of class or object or something like that. And you'll see that in a lot of the packages that you use. And if you go through those nomenclatures in your own code, it'll start to make a little bit of sense when you see how other people name things. Yeah. Yeah, exactly. There are a bunch of style guides. I mean, there's one in particular. It's like the
Python.org,
peeps. Yeah, I was like, it's the yeah.
Python.org on their dev page. I'll put a link. I'm going to update with the repo and a couple other helpful resources onto the event page so you can come back afterwards.
Yeah. Yeah.
The object.function still seems a little abstract to me. Can you give like a example of how you can wrap your head around that?
So I would say in integer, right? Or in this case, a floating point number, right? So if I type B, this is a floating point number. The floating point number has a number of like things that it can do, right? Those would be the methods that are associated with the floating point object. When we're just talking about a number, it's like, sure. As we get to talk about like what a string or something like that, you can do like uppercase or lowercase. It starts like, okay, that makes sense that a string can do those things by nature. So now then the question becomes like, okay, so like how do we get our function to do things, right? Or how do we get our object to do things? And we can say, well, okay, we can run some function. And so that's effectively what we've done here is we've said, get this object and go grab this function from it. And right now we're just treating the function as any other thing that we would get. And it's not until we add the parentheses at the end of it that it thinks, oh, you wanted to run that function, right? And this becomes really useful when we do things like, and I'll actually show you an example of this later on, when you can do things like pass a function to a function, right? Where you can sort of nest inside and get complicated. Does that help? Did that clarify at all? No! All right, ask that question again once we get to the end of this notebook, and I think then maybe I'll be able to give you a better answer. Okay, so this is Markdown. This is the sort of standard Markdown language that you can Google. The notebook cells can be code, raw, or Markdown. If you set it to be Markdown, it'll render it and make it look a little bit pretty. That's all I'm doing here when I have these like headers between sections. And this is a really good way to start commenting your notebook as you go through, right? And hopefully everybody is familiar with the concept of Markdown. Yeah? Yeah? Okay, good.
Yellow stickies up if you can make something bold and mark it.
Oh, that's a good way of doing it.
And the answer is put an asterisk on each side of the object with those spaces between the name and the asterisk.
Right? You can do all kinds of things to like break your Markdown and do things like that. But so when we talk about data types, we can do things like a equals 1. You can get a really pretty common error in old versions of Python by saying b equals 1 over 2. And it would, in Python like 2.6 or something like this, this function would end up being, I believe, 1. Right? Can anybody guess why that is? So they fixed this, what I would argue is a problem, but it now equals 0.5. But so the problem before, and I sort of like this problem because it made it really easy to explain the concept of a type, is that 1 and 2 are both integer types. And so if you divide an integer by an integer, the output should be an integer because you're not bringing in any other kind of type. And so when you would do that, it would just give you the integer that best matched your equation, which is a terrible plan, right? They've since updated this and they fixed it so that now we get something that makes a little bit of sense, right? When you're using Python, I should note that equals is always equals. There's no arrow thing, which makes me uncomfortable. This is just like a redo of some of the things that I did, right? A equals 1, you can print the type. A equals 1.0, you print the type. And now all of a sudden we're getting different types, right? This is an integer and this is a float. And I go into detail on this not because I really think that you need to know the difference between integers and floats and things like that, but because type errors will dominate your life if you don't think about them, right? So I'm gonna scroll through and not run some of these bits of code here. And I'll let you guys, you can play with them if this is something that you want to figure out. all I'm doing here is I'm just showing some different functions that you can run on integers and floats that'll err on err on integers, but not run on floats, and vice versa. And it might be a good way for you just to get a little bit of a feel for, in like a really simple playground, when you use the dot operator, when you put the parentheses behind things, and things like that. But what I want to do is I want to move on to some strings, list, and dicts. The main way that we sort of think about data in Python, right, is not really in terms of integers or floats, but we often, very often, think about lists, named arrays, or and things like that. So let's start off by saying, do something stupid. My string equals, this is my string. And because we're talking about types, we're going to print my string. This is my string. And then we're also going to print type my string. So this is now a string. If I wanted to create a list, I can do my list equals, and I use the square brackets, and square brackets always denote list. And I can say, this is my list, right? And so here I'm specifying with square brackets list, and I'm separating everything with commas, and the things that I'm separating are strings. So if I print my list, and then I print type of my list, it printed exactly what you would expect, right? It printed the thing that I typed, and it is a class list. So now I want to draw your attention to, okay, cool. We can have a list, we can have a string. All of that makes sense. This looks a little bit silly, but sure, I can get used to that. We need to talk a little bit just about indexing. So I can say this, so I can say my string of 0. Does anybody know what this is going to print? So these two are going to print, are they going to print the same thing or different things? Different things. Are they going to print, what's going to be shorter? Yeah, the first, right. So here we go. Now we got a class list. We're printing T. That's just the first item here. And then this, which is the first item of my list. And of course, we can do this thing that we always do that ends up being complicated later, but we do it anyway, where we index the thing that we're indexing, right? And now what are we going to print? Okay, now I'm going to show you something that is weird to Python. What do you think we're going to print now? Yeah, so this is going to do from the end, right? And so I want you to note something. This is like I just showed you like a sneaky move here where you can index from the end, right? Which is very useful in some situations, always sneaky. But the thing that I want to point out, and then I want you guys to sort of take note of, is that I indexed from the beginning starting at 0, but I indexed from the end starting at -1, right? And this is actually something that will eventually introduce errors in your code when you say things like, I want something for like the length of this list, or the range of this list. Like this indexing can become pretty important, right? So now, just like we have with our integers and floats, now we can talk about the things that integers and floats can do. So we can do something like, instead of just printing my list here, let's just copy those, create a new cell. We'll work with these here. And so we're going to say dot upper. So what do we think this is going to do? It's going to make it uppercase, right? So this is going to take a string, index the first thing, and make it uppercase. Now, what is this one going to do? right? So this is a little bit sneaky because now I said this is weird, right? I have an upper thing here. So if I go print my list of 0, and I'm going to print the type of this list. Oops. So what is the type of our object here that we're returning? Yeah. So this is basically a string because I'm getting the first element. Now, what if I remove this and this? What do we think it's going to do? Error. Right? And it's going to say because, so I just checked, it's a list. And it says, whoa, 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 whoa. Your list object has no attribute upper. Because uppercase, making something uppercase, is not a thing that a list can do. That's a thing that a string can do, but not a list. Right? So we're playing this, we can play this game like this. We can say, okay, cool, cool, cool. So then, I can, what can a list do? Right? And lists can do a lot of things, but a lot of these things seem pretty boring, and they have to do with a list, right? Not something that a string can do. So uppercase, lowercase are things that you can't do with a string. We can add some functionality to, we can do the same thing for my string, right? We can say capitalize, format is ASCII, et cetera, et cetera. We can do something like my list.append 8, and then print my list. I'm going to comment this code out, and I'm going to put a comment here that said, this errors. It's because we're not looking at a string, and lists can't be uppered. Yeah.
How are you getting the possibilities after my list?
Oh, I think I said that earlier. So if you type my list dot, you can hit tab.
And then tab.
Yeah. So it's like the autocomplete. So my ability to do this, to append something here, right? To append 8, which is going to be an integer, to a list is why you can't uppercase a list, right? Because I can add anything to that list. I can make a list and append it to my list. A list doesn't care. Lists don't care. Okay. I want to just do a little bit more indexing and just show you a couple neat Python tricks. So we can do my string. Let's just print my string. What is it named? This is my string. Cool, cool, cool. And so we can say my string of colon like 8. And that's going to print the first 8 things. And if we do 8 through, or if we do like that, it's going to print the last 8 things. So basically, the colon operator here can be used to fill out in either direction. Yeah.
You said that prints the last 8 things?
Yeah.
Or it prints starting from the 8 things?
Well, let's see. So the question is, does this have, if I do this as, so it prints starting at the 9th, like starting at the 9th element in this case. So starts at the back and counts 8. 1, 2, 3, 4, 5, 6, 7, 8, inclusively. And this goes back to, I think it's because this is the same kind of BS with the indexing where it doesn't, it's like, what is the last element? Is that, I think this is, or maybe you're right, maybe it is coding, it's 8 forward. Yeah, sorry. Then you were right and I was wrong.
This is how you get retractions in science.
Yeah.
Not you, Drew, never you.
It's because I don't publish in science. Nailed it. Yeah.
I was just curious, the spaces before and after your, I guess, the functions you're using, is that a code like best practices? Kind of thing?
It's not part of the written best practices, but I find it helps me read the code, right? So I try to like, if I'm doing like, if they're going to be multiple parentheses, don't let your thing end with like parentheses, right? Make your thing end with like, encapsulate one idea and then put spaces on either side of it, and then the next idea and then spaces on either side of it. But that's a total preference to me. I just find it easier to read that way. So I try to implement it that way. Okay, so now we're going to move on to another data type, which is a dictionary. Dictionary is like a unique Python object. Dictionaries are effectively just named lists, right? And so I can do something. So you define a dictionary. So I can say, you know, when I taught this class and I call it my dict, everybody laughs at me. So now I have to type out something longer. So here, whoops. I've defined a dictionary. I can print it out. I'll print the type of it just so we're sure. Print type my dictionary. And so here we go, my dictionary. And it's defined with a curly bracket. And it just goes element, like this is the name of it, colon the data. Like name colon data, etc. So in this case, I've named it 1, 0, 1, 2, 3. Right? So if I type print my dictionary of 2, what do you think we're going to print? Yeah. Now I'm going to do something that really messes with us, right? Now what's going to happen? Am I going to print the same thing or a different thing? Different thing, right? So I use this example because I really want to drive home the idea that lists are inherently ordered. When you have a list, it has a first element and a last element. A dictionary has no order to it. There's no inherent order to it. So if you try to index something by number in a dictionary, right, you will usually get a type error. The only reason I didn't get a type error here is because I named things, I named the elements in my dictionary numbers, right? So I could just as easily say, right? So what do we think is going to print here? Here, yeah, right? This is because I'm trying to index into a dictionary using a number, but it has no idea what that number means, right? Whereas I can do something like this where I can say Steve, and now I get my element out. So DataLab has contextual help. I can let you sort of play with these things, and I think it's just really the key parts to remember are when you're defining a dictionary, curly braces, 0 : thing, right? When you're defining a list, right? You want your square brackets, and you can play around and just see what functions those have, try to run them. You can look at your little contextual help over here, which will tell you some things. Now, I want to introduce you to one more thing, which is something that is unique, another uniquely Python thing, which is the tuple. And I will say that I'm to the point now where most of my key errors have to do with tuple use. Tuples are this weird Python thing where they're like, well, you know, really, if we wanted something run really fast, we would want it to not have any, like, we don't need our lists to be able to sort themselves. We don't need our strings to be, like, come on. Like, we just want it to run fast, and then what fast means minimal overhead. We don't want it ever worrying whether it can do other things and stuff like that. So tuples are kind of like lists. But tuples don't have methods. They are faster than lists, and sneakily, they are immutable, which means that if you define a tuple as being 2 things long, you cannot add a third thing. It will always be 2 things long, right? And this is one of those things where if you're dealing with tons of data, you'll probably need to start thinking about tuples. If you are not dealing with tons of data, I would say like 80% of the time, it doesn't really matter, and you probably shouldn't worry about it. The difference between a tuple functionally in a list, right, is I can say my list equals 1, 2, my tuple equals 1, 2. Right? So we have list, tuple. I can, my list dot append 1, and my tuple dot append 1, and we're going to error when we try to append to the tuple because you can't do that. Now, in order to show you an example where tuples were actually more efficient, it would crash my machine, right? So I think that it's important to know this because when you print something out, so if I say print, you're going to find this in other packages that you use, where you're going to say print like my tuple, and you're going to see it printed like this with your curly bracket, and you're going to be like, aha, that is a tuple, not a list. Now here's the thing, most of what you want to do is going to be just fine. It's going to work the same way with a tuple or a list. So I can do the same kind of, so I can print my tuple of 0, right, of 1, but I can't do things like sort. I can't add things to it because tuple doesn't have any functions or any real utility. If you ever find yourself in a situation where you really want to do something to a tuple, you can do something like this. You can say my tuple as list equals my tuple list my tuple. And I believe this works. I haven't tried this in a while though. Should have practiced that. Yeah. Right. So this is just basically saying like, make this thing into a list. And that sort of construction where you say list of something, you can also do that for items or things like that instead of specifying with a square bracket. But you might see that online some places, but I would don't do that. It's like a added complication. Yeah.
So Drew, you mentioned that you would crash your machine if you showed us an example, but could you just talk about an example?
Yeah, I mean, really the problem is like you would need to run something like a timed function that would eventually so the overhead of running Python is non-zero because you have to load in a bunch of libraries and things. One of the reasons why Python runs kind of fast is because they like treated the packages as like a serious thing where the base code to run packages is just not available in base Python. And base Python is like kind of small. But when you try to like run some kind of compilation or something like that, what it'll end up doing is trying to like compress your code as much as it can as you're running. And so the result is that a tuple can take up less RAM because it doesn't have to have additional things in it. And computations on it will run faster because you can, if you have it like in a loop, for example, you can store it more in a cleaner way. So I would say for most people who are doing this, like if you don't already know, well, let me say this. If you're interested in using Python and thinking about these kinds of problems, I would recommend you not think about Python, right? Python is like fast compared to R, but if you're gonna write, like if you're trying to write super fast code, go write in C or go write in, Fortran will always be faster than C because it does less, right? So it's like an old, like a 70-year-old astronomer who I was trying to convince to not write in Fortran. And he was like, if you can write something faster in whatever the hell language you kids use. Yeah, he was basically like, no, bro, I'm still using Fortran. Okay, so now we have an idea of like integers, lists. There's one more sort of just basics of Python thing that I'll introduce, which is for loops, while loops. Hopefully you've all been sort of generally exposed to the idea of loops. Here I'm going to say I equals 1, while I is less than 10, print I, and then I equals I plus 1. Woo! Right? I just wanted to write that out because the syntax for this is a little bit different than you might have seen in other languages, right? We have while, there's nothing, you don't need anything here. If you wanted to parenthesize that, you could. And then I less than 10. And then here we use the colon to denote that something is continuing on. And this is a part of something that will continue on for multiple lines. So this same colon is used if we define a function. The same colon is used if we have a class or something like that. And the other thing that we note here is this indentation. The only way that Python knows what's in the loop and what's not is this indentation. So if I do something like this, right, what am I going to print? Did you say I? 10, right? Because it took I, it set it to 1. It ran through this loop 10 times. It set I to be 10, and then it printed it, right? If we want to print it every time, right? And now we start at 2 because we added before we printed, right? But this is like a very basic thing. It is also the thing, like, this is the kind of error that often gets made. The function is often longer, so it's harder to find. But it's like, one line like this. Jupyter Notebook knows this, and it's like, oh, dude, don't do that, right? And it'll error, and it'll say, unindent does not match any outer indentation level, right? We can also do a for loop. So one of the most elegant ways to use for loops, and I would say when I'm writing Python, I very rarely have a situation where I want a while. We often use for loops, and I'm just going to print my list. Right now it's 1, 1, 2, 1. And I can say for item in my list, print item. Right? Or I can say item +1. Yeah.
So for the loops, there's no end of loop.
There's no end of loop.
And then if you've got loops within loops, you're going to have to keep.
Yeah. So I can say for item in my list, for, let's do something absurd. While like j is less than item, print j. Right? Oh, what did I do? I didn't define j. Right. So this is just things get increasingly nested and things like that. And usually if you hit some sort of nesting level that makes you uncomfortable, it's probably because you should have defined an object, right? You should have compressed it somehow. You should have said like, okay, like these inner loops should be their own function.
And then which options will do the indentation? Code does it, Markdown does it in terms of giving the indentation automatically. So
I hit tab to indent. Yeah, I just tabbed to indent. And the notebook is smart enough that it adds spaces here. Inevitably, when I use a new computer, if I'm like on some server someplace and I'm writing in VI, they don't have my VI environment, and I hit tab, it puts a tab in, everything looks nice, and then I run the code and it's like, what the fuck, dude? Right? And that's because when I tabbed on my like other computer, it actually inserted a \T instead of typing 4 spaces like a rational notebook should. Okay. So this has been a little bit boring and dry, but I feel like this is the sort of foundation that you need to jump in. So good news is we're basically done with that. The other thing that I want to tell you just about Python is that Python, for what we want from Python, it doesn't really do much, right? Basically everything that you will ever want to do with Python, with a few very small exceptions, will be a part of packages that are not part of that are outside of the base Python. And so you can import packages to increase Python's functionality. If you install with Conda, you should have a bunch of these packages installed already. And here are some of the sort of packages that we'll talk about. And you can just import them with Pandas as PD. And I want to just run this really quick here and just show you one more little trick before I leave the sort of the world of basics here. And I'm going to say PD dot, really? So my tab didn't work, but you can see that you're going to get all of the same kind of help that you're getting from a float or something like that is going to be in your contextual help. And I did. I mean, it says it has a number. Yeah, there we go. Okay, there we go. It worked. Maybe I just typoed. And so you can see all of the things that this object can do, right? So the same logic that we used when we talk about type errors, when we talk about what an object is, like everything in that you import a package is just a really fancy object. And that object can have objects in it, and we can do all kinds of fancy things with it. But the reality is all of the sort of tools that you've thought about so far today in terms of what can I do with this object, in terms of how can I manipulate this object, they're all going to be the same kind of things. And very often, you'll get type errors for objects and things like that. So how do we feel? Do we want to take a short break, or I feel like I'm running slower than I wanted to? So I want to just push on, but that seems rude. Going once, going twice. Sold. All right. So I'm closing the notebook for how to Python. And I'm going to move on to talking about this, about how I think about analyzing data and how to analyze data. So a few notes. This project is on GitHub, which hopefully you've all got. I used Cookie Cutter to organize this. I mentioned this before. You can install this if you run this on the command line, and then follow the prompts to create your own project. The first thing that we're going to do when we have any project is import packages. In general, it's a good idea to import all of your packages right up at the front end. The main reason for this is that if I open your notebook and I don't know that I need some packages installed, it's going to be annoying when I start running through your notebook and then 20 minutes in, I'm like, oh, I need to install that. Well, that's a deal breaker for me, right? So here are the packages that I'm going to install. I'm going to run this line. The packages, these are all very well sort of thought out, clean packages that are what I would refer to as entirely baked. Pandas is a fantastic one. It's the goal of Pandas is to bring the concept of a data frame into Python. Matplotlib is the workhorse of plotting in Python. I would argue that it is terrible. But nobody wants to write low-level plotting packages, so that's the best we got. There are a few, and in the advanced notebook, you can find an example of one where they're trying to push the limit of what you can do and trying to write a new plotting package, but I would argue that that one is not fully baked yet. Seabourn is effectively a wrapper for Matplotlib that makes science plotting easier. So if you want to do a bar plot or a violin plot or something on a data frame, it just does that. And it's getting towards the kind of utility that you would get in something else. I also imported NumPy. The reason why I import NumPy and not other things that you could do math with is that NumPy is fast. It was intended to be extremely fast matrix math. And then its mission got a little bit blurry, and then they just started doing any kind of math that's fast. And so if NumPy does it, you can assume that it's going to work quickly. If you import the same kind of functions, I'm going to use it in this log scale things, which is you don't need NumPy to log scale things. But if you import log scaling from some other science package, some homegrown thing from the Python base, or even from the math language package, it might not run quickly. And then RE, because I wanted you to know that you can use regular expressions in Python just like any real language. Okay, so my father just moved to Davis as an old man, and he's super proud of his Olympics, because he was the team leader for the United States Olympic table tennis team. And so I've been hanging out with him, and he's wearing every shirt that he has the Olympic rings on it. So I try to design this around this sort of idea of we're talking about the Olympics. So I found some data online. This is the data that I sort of briefly opened earlier, which we can find in our data raw athlete events.py. This is just something that I found online, and it has just a ton of data from this is a person, this is their sex, this is their age, height, weight, what team they played for, what games they were in, year, season, etc., what sport. I'm mostly going to ignore this data, but I just want you to see it's a wealth of data, and it's a pretty good data set if you want to just sort of play. And the way that I would recommend learning how to use pandas is going to be to sit down and to play with how to oh, I wonder about that, and then try to play with it and see how you would organize your data frame to do it. So we have our Olympics data file, and we're going to use pandas to read it in. So the way that we read in with pandas is PD, because I imported it as PD. In general, you can import things in whatever name they want, whatever you want. I could have imported pandas as the only real pandas. And that would have been super annoying to type. And it would have been super annoying to copy from Stack Overflow, because there are standard nomenclatures for when you import pandas, import it as PD. And if you do that and you sort of like ascribe to the nomenclatures that people write out ahead of time and what the originators do, then oftentimes when you look at Stack Overflow, it's going to have those things. So I'm going to do pd.read CSV, and I'm just going to input df Olympics file. Something happened. That seems great. Now I want to look at it. So you may have noticed that I've been doing this a little bit before, but we can do something like print df Olympics, right? And then it'll print something like this. But the Jupyter Notebook actually has something a little bit fancier, where if I just say df Olympics, it'll organize it for me. It's like, oh, this is a data frame. So as long as something, whatever is the last thing in your thing, it'll load in. So it looks like I did load things in. It looks like I have ID, which is I don't seem to need. So I could drop that if I wanted to. But otherwise, that's good. I can do something. So you'll note it didn't print the whole data frame. It did this ... thing, and it's a little bit hard to scroll. So let's just do print the head, and we'll say 2 lines. Right? And that'll print the first 2 lines. I can similarly print tail. That'll do my last 2 lines. Okay, things are working. Right? Nope. So, okay. We can talk about what our data frame looks like. It looks just like the file that we loaded in. So we're in good shape. What column? So now we have to think about like, what do we actually want from our data frame, right? So the first thing I do is like my dad, he was in the Summer Olympics. That's where table tennis is. So I want to get rid of anything that's not Summer Olympics. Winter Olympics just seems very un-California, right? I grew up in Minnesota. I got enough snow, right? So we'll go df Olympics, and I'm going to select those parts of the Olympic data frame where df Olympics season equals summer. So what I'm doing here is I'm saying this variable is now going to be equal to what this variable was. df Olympics, I'm selecting the season variable from this, right? Yeah.
What if I forgot how season was entered? How can I check that without actually looking at the data?
Like, what do you mean?
Just the levels.
Oh, so if you wanted to see the levels of season, like what seasons exist,
Yeah.
you could do something like print df Olympics seasons dot unique. I believe this is just going to print. Nope, did I do that wrong? I think that this is effectively a type error. It says a key error, but the error is because did I spell unique wrong? Is that what happened? Let me just see. I gotta debug what I'm. I don't remember. Pamela, I've been blanking on this right now. Yeah.
Isn't the CSV on the GitHub?
Yeah, it should be. What? Isn't it in data, raw?
There's no data.
There's only a notebooks folder? So if I go to my
Olympic data, but it's JPY and the on the notebook.
Why is it? Oh, you bastards. I see why. I apologize. I had no idea. Hey. Yeah, I'm just gonna do this. So the reason why that was is because the cookie cutter thing that I used at the last minute thinks that one should not post data to GitHub. So it tried to do something smart and was like, yeah, anything you put in this data folder, we're just gonna not post that to GitHub. When you do post to GitHub, that's probably a good practice. It turns out not the best practice for this. So did that actually post now? Oh, fuckers. I got distracted by. There we go. Sorry. It's really going to be a bummer if you can't find it. All right. Fuckers. Yeah, I don't remember how to print the is unique. I just don't do it enough.
Let's take a 2-minute break so that everybody can get the data downloaded and make sure that you can rerun the last step that Drew did on the notebook. Where was it? Right. So
This
you
one,
can at
yeah.
least look at the head of it. So take an execute, and once you can see the head of the data, go ahead and put your realistic view back up, please.
For someone who doesn't even know where to begin to download data.
I don't know where to download the data. Where do we download it?
From the GitHub. Oh, I know why. I know how I do it. No. First of all, there was a typo in my thing. So everything I tried before wasn't working. Yeah, but that gave me, oh, look at that. So it was the first thing that I tried. I just misspelled season instead of seasons as the column of my data frame. Very sneaky. Yeah. Mhm. Ah. So I think that has to do with that you're not yet.
So I just highlighted these things.
You can just run. So it looks like, so it depends on how you installed, but probably what happened is when you installed it, you didn't install Pandas. So what you can do, you can actually run it from here. So if we just go like this, I'm going to go Control M, A to insert above. And then I'm going to do pip install Pandas. And then that should, but probably you're going to have to do this for other packages if this, right? So it may be that you install like Miniconda or something. Yeah. So what Miniconda will do is it'll not install any of the fancy things. It's like, you just want like the basics. And so Pandas is, I would call it basics, but if you wanted like a really minimal version, then you wouldn't want that. So that's like Miniconda is like you install as needed versus just install a bunch of stuff and I'll figure out what I want later. Yeah.
So do you specify, like when you're doing the Conda installation, do you specify like the individual packages,
so if you install Conda or Anaconda, it should have installed a bunch of things.
Okay.
If you install Miniconda, it'll just install like minimal stuff.
I did Anaconda.
Yeah, so it should have installed Python.
So
or Pandas.
it's also giving me the like Pandas error, and I don't know if I need to load. I mean, I'm in the base environment, so it should. It might have been in another environment.
Yeah, so I think that the problem is, so, okay, I just wanted to make sure that that was airing at this thing. So my guess is that you might have Pandas installed in like a different environment.
My guess is
right?
it's in a different
So
environment.
the way that I would recommend ensuring that you're installing into the environment that you want to be in is like, so if you're in Jupyter Lab, you can type > pip install,
Okay.
and that'll install in the environment that you're currently loading, right? Like
With space?
pip install
Okay.
space Pandas. Right, so that'll install it like in this environment, in this work, like whatever version of Python you're running, it should run that one.
But if you do it without the exclamation point?
So the exclamation point is like basically saying run a Unix command from the notebook.
Oh, okay.
Yeah.
Oh, so it actually does it.
So it's actually doing it for the environment. Yeah, exactly,
Okay.
exactly. Yeah.
Makes sense. Thank you.
I don't know. I have a question.
Yeah.
So Colin is trying to load in the data.
Yeah.
We downloaded the data and we put it in a document. I don't know how to reference the documents from the notebook. I don't know where the notebook.
So yeah, so you can find out where the notebook currently is. I'll just do that up here actually. If you can get your present working directory in a couple ways. You could run the Python command to get your present working directory, but you can also, if you just type ! in something, it should run the Unix command. So if you're in Windows, you should be able to run whatever the DOS command is to get your present working directory. Change your present working directory? Probably the easiest way is not to change the present working directory that your notebook is in, but rather to either move your notebook to a different directory and start and load it up again, or to just give the full path to the file that you're trying to access, right? Because the notebook isn't restricted to finding things in it. So it can find anything as long as you type in the full path. All right. It looks like there's still some people, but I know at least 2 of them are still installing Pandas. Did you get somebody to help you? No.
I can figure out how to download so I have the CSV there, but I don't know how to get it to integrate.
Okay, so if that CSV is right in this folder, you should just be able to delete the .. /data raw.
Just here, just like this.
Yep.
And then just do that.
Yep. One more character. Yep. And that should run.
That runs.
If that was, did that run? Yeah. Yeah, I think so. So DF Olympics file is athlete events. Oh yeah, sorry. You have to actually run. You have to type read CSV.
Oh. Okay.
Yep. Sorry. So you just define the file name.
Yes.
I'm just like quasi looking through the reflection on your screen. Yeah.
Thank you.
Yep.
Yeah, one of these days, No, it's really fast. I literally already did it, but it was just the fact that I wasn't paying attention. Because like, I think I did it in a class.
So
Yeah.
I dropped that file into the root of the main folder, and so then I would try to assign it here.
So may I type?
Sure.
That?
Yeah.
So, so I have to, because it's Windows, I have to think for a second.
No, it's
Import.
Linux.
Oh, it's Linux. Oh, good. Then I was like, oh, this is like a, but I should just be able to do like this. So I'm going to run the Linux command.
Figure out what the
I'm going to figure out what directory you're in.
Yeah, that's
right?
what we were wondering.
So you're in notebooks.
Okay.
So then if it's in the root directory, you should be able to go .. /. Is that right? I don't see where athlete events is in. Yeah. Did that not?
Do you mind if I
They're
scroll up
tokenizing.
the notebook on the
Oh, yeah. Go for it.
So bang pwd gets you a system command.
Yeah, bang anything.
That's cool.
Yeah. That doesn't mean things to most people, so I don't really. But I was just using it to like pip install into like this environment.
Yeah.
Like if you ever are like, oh shit, which environment am I installing in? Just do it in the notebook that you want to run things from.
Yeah. Okay.
Yeah. Why is this airing? What is it airing on? It's airing on that file. It says error tokenizing data. Parser read and rows.
Seems like an awfully complicated error message for not finding the file.
Yeah, I think that it actually did find the file. Expected 1 fields in line 49, saw 2. Let's take athlete events. Oops. Sorry, oh, you're in the notebook. Ha. Okay, that was why I was confused.
Oh, what did you think of it?
No, the lab versus notebook has the bar on the side, and I was like, why is it looking so weird? Sorry. I think that this has to do with the file that you downloaded might be slightly different from what I had. I'm not sure though. Let's so I think skip rows equals like 2. I expected one field on line 49, saw 2. So there's something wrong with the file that you're reading. The way that I would check that is I would just open it in the CSV and I would scroll down and see what happened. But I would probably just download it again is my best bet.
Okay. All right.
It's like, that just, it feels like something weird just wrote that file.
Okay. Is your current notebook within this folder somewhere?
I think we're gonna run out of time here. So I don't know whether I want to try to
So can I see that again?
just show stuff.
Got it.
Because this is gonna end at about 4. What I'm gonna do here is I'm just gonna spend the rest of this time trying to push through this. But it so turns out that the Python user group is immediately after this and runs until, so I'll be here until 5. So for like another hour. And I'm happy to sit down and talk with people and if they want to go through and try to get this notebook running for themselves. I think, I mean, honestly, I think that the skills that you need to walk through this notebook, there are going to be 2 kinds of skills. One of them is the skills that we tried to go over in the first part. And the second is skills in thinking about how to organize data and things like that. Right? So let me just go through and so I drop, did I? No, I already did that. Let's start up here. So I still have my data. I'm gonna, I can check, Pamela asked if I could do unique or if I could find out what levels were there. So .unique will just give you all of the variables that are in, like all the unique things that are in that variable that you print in that column. So I get summer, winter. I can say DF Olympics equals DF Olympics where DF Olympics equals summer. What did I do wrong? Oh, Olympics, right? And so that'll give me now same kind of data frame. Here I printed it instead of using Pandas to print it. So we can do something like how many medals do different countries win each year? So I'm going to use a fancy function. This is something that hopefully people have seen in R or something like that. Where I'm going to group by. And I'm going to say, I want to group by, and I'm going to give it a list of things to group by. I want to group by team, which is the country, medal, which is whether they won gold, silver, bronze, and then year. So what year did they run it? So if I did that, that's just going to give me a group by object. But I can do something with that group by object. I'm going to say count. And so this gave me team, medal, year, and then it has like a bunch of other things. But I told it to count, so all those things are basically the same because they're just telling me how many things they added up into that column. So really what I want is count where ID. And so now I have team, medal, year, count. Yeah.
Is there a way that you can organize like your code onto multiple lines and it'll still run? Or like to use like in R, the require package has like a pipe function. Is there an equivalent? I can imagine like if you have multiple functions.
Yeah, so you can do things just like, I think, like, does that work? No. That would work. Right? So you can arrange it onto multiple lines just as long as you indent, basically. But there isn't like I don't know if is the R pipe function the same as like a Unix pipe function? Versus like take the output and put it into the next thing? Yeah. So there's no like very clear way to pipe in Python where you just say like take the output of this and put it into that, other than nesting it inside of the function, right? So I can print the winners, right? We're in that space. Now we can reshape it, because this is sort of like a weird shape to look at our things, because now I lost some of the prettiness of my data frame. And really what I want is I want it to say, like, this was a team, this is the medal, this is the year, and then this is the object that I'm looking at. So I'm going to say df winners.unstack. So I'm going to unstack my data frame. Medal is the thing that I'm interested in. I don't want NANs in my data frame. Like when they didn't win medals, I want them to have won 0 medals. So I'm going to fill NA with zeros. And in this case, I'm going to have to reset my index. Well, I can do it without the reset index and show you what it. Right? If I did I do that wrong? Oh, because I already unstacked it. This is why you should not typically put data frame manipulations across multiple cells. Is because then you screw up, right? So you should, I mean, and as I go down this, as you scroll through this notebook, and hopefully you can get time to do that, you'll find that there's some like tips for how you should organize your notebook with specific things. In this case, now we've got the kind of thing that I want. So it just says, you know, team, year, bronze, number of bronze, number of golds, number of silvers. So now that I have my data frame, I can do something like create a new variable, so the total number of medals. So that's going to be if I just print my data frame here, I see it's bronze, gold, silver. If I want to know how many total medals, it's going to be df winners where. And here I can do something sneaky where I give it a list of bronze, gold, silver dot sum, right? And I just tell it which axis to sum across. I think this should work. I'm also using tab to autocomplete the line that I'm typing. I'm not just typing super fast. Yeah, so total medals now added there. So now is where we can do some things where we start to get a little bit interesting. So I can create a Seabourn plot. So I can do a bar plot where I'm going to say my x-axis is going to be team. My y-axis is going to be, well, I guess I gave myself a note to, so I guess gold medals. And my data is going to be df winners where. Now here I'm going to select, I don't want to select plot all the data frame. I would just want to select those where the years are a certain thing. So I can just directly jump into it and say where df winners of year equals 1992. And ta-da, we have a plot. Now there are a couple things about this plot is that it didn't figure out for me that I should, my axis is like this. And it's like a little bit taller than it should be. So I can do a few pretty simple things that'll fix that. Where I go SNS, I can say, I can name a figure and an axis with a Matplotlib figure, which I always call with subplots because it makes it easier to change it later if I want to add things to it. And I can say fig size equals, and I'm going to give it a tuple where it's like 5 by 15, something like that. And I always have to Google this, but I Googled it earlier. So you have to set the tick labels and give it the labels that you want and where you're rotated. So what I'm doing is I'm saying set my tick labels to be what they already are, rotated 90 degrees. Whoops, I did the wrong order of these things. So you can see my plot is like, I made it longer. I wanted to do it the other way, right? And so now we have a plot of who won medals by year. And I think, I mean, there's a lot more in this notebook which you can do. I loaded in population data to ask whether winners are big countries, and look to see whether rich countries were winning. It turns out rich countries win. Yeah, throw money at the problem. The only thing that I would really encourage you, if you go through this notebook on your own, to pay attention to is this comment here on error messages. I think the rest of it is a little bit self-explanatory. You'll have to like think about how to do it when you're specifically when you're like unstacking, melting, merging, pivoting. That's the hard part. Everything else that you're doing is just passing like lists to variables and things like that. And as long as you know what a list is and what a data frame is, you should be in good shape. I want to show you just like really quick what happens if I run this. Because, so this is, I think, maybe the best advertisement for Python that I can give, which is that there's some new things that people are working on, such as plotting with like Altair. So in this kind of plotting, it's the same kind of thing that we're looking at, where I can make a plot, and that's fine. I'll zoom out a little bit, right? But the neat thing about Altair is that you can add like a little bit of code. So in this case, just adding one line from this previous plot to this plot to allow me to mouse over and get the information from this, right? And then I can say, I can do something that's even a little bit fancier than that, where I, instead of having one plot with an interactive element, I can actually have two plots with a shared interactive element. So this is the total medals by GDP, and then over there is a plot of year, but I can actually click and see like, oh, okay. Like for the USA, they had a good year in 1992, but it turns out, I think there were just like more medals in 1992. I haven't actually plotted that yet, but a lot of countries got more medals in 1992. So that's the kind of thing that I think that you can work towards. And it's, I would argue that this is a pretty advanced move, and this package is like half baked. So if you do, there's some weird things that you can do that will just like break it. If you try to add a legend to this plot using their default legend style, all of this plot will fall, like for some reason it'll just get this big. And it's a known bug and they're fixing it, but they haven't fixed it yet. And then of course you can do fancy things like plot it on an actual map. Right. And these are things where I think, you know, once you get things into a data frame and you get used to thinking about how you want your data frame organized, which I think like that's the hard part, is thinking about like what data do you want, how do you want it organized. Once you get those kinds of things, you know, making this plot is like reading in my file, changing names, because apparently United States of America and United States aren't the same. Merging my two data frames, and then plotting. Right. So there are things like that where when you find the right package, can really help you do things. So I apologize for not being able to get through more of this notebook, but I think now is a good time to let people who want to get out of here get out. If you guys want to hang out, I can keep going through this notebook, or I can keep answering questions. But.
And on that, if I had a challenge question, if you can find your dad.
Huh?
If you can find your dad in the data set.
Oh, no, he did not win.
Oh,
He didn't play. He didn't win. He was the team leader for the United States team. So I can find people like Gao Jun and, you know, Sean Trainer and people like that who played, who he managed, but he's not in there. Yeah. Yeah.
Is there like a function in Python that you can use to query or like get help for other functions? So the equivalent in R is like a little question mark.
I'm going to interrupt because we're going to Q&A. So before you leave, please do fill out the feedback forms. You can leave them right there by the sign-in sheet. We really, really appreciate that. And as a reminder, Pod meets every Tuesday at this time. So if you want to keep learning and practicing your skills, or if you've got a package, you want to know how to use it, this is a great resource and time to get in-person help. So thanks so much. And for those of you who want to stick around, you're welcome to stay till 5. There's a video. Have a great rest of your evening.
Thank you guys for coming.
Thanks, Drew, so much.